Welcome back, Math 10s. We're going to be doing 4.2 here, graphs of relations and functions. Just recall that before we're going to be using our vertical line test that we did last time, just holding our pencil or drawing a vertical line through graphs. And every one of these is a relation, as x relates to y, an input to an output. But if the vertical line passes two or more points on that graph, then it is not a function. Okay, so let's get right into it. We're going to be looking at just some few examples here, very short lesson actually of just interpreting some graphs and whether or not they relations or functions. So really important that we always look at the labels on our axes, the horizontal, the vertical, the up and down, and the left and right. We need to be verifying and looking at what are the variables and how do they relate to one another in the situation. So our first situation here in our example, we have a young child climbs the stairs of a curved slide, stops at the top, then slides down. Which graph best represents the child's height above the ground in relation to time? So we see with all three of these, let's call this A, B, and C. In all three of them, they have the exact same start. And it looks exactly like stairs of someone going up. And it's a small child. So they take a step, they stop, they take a step, they stop. So it does have this step like graph as the height increases off the ground. And then with all three of the slopes look slightly different. So we have to think about what happens when a child scoots over and starts to slide down the slide. Well, I don't know about you, but most slides I've seen out there, definitely as you climb up the ladder here, you get to the platform and it's steep at the beginning and then slows you down at the end so that the child lands safely at the bottom. And we can see that here in our first graph, we can see that it looks like as the height is changing at a constant rate, um, going down over the course as time goes on. And that's not really how a slide works. You're going to start off quick because gravity's going to push you down the steeper part of the slide, and then your height's going to slow down, which in C we see that's the opposite here. It starts off really slow and then gets really fast at the end. That does not look safe for a child at all. And definitely this one where it starts off quick and then has a bit of a bend to it because the student or the child is slowing down to land safely on their feet and enjoy the ride. So it's definitely going to be B in this case. How about this one? Let's pay closer attention. We want to know Sabrina rides up and then down a steep hill. Really simple concept here on their bike. Now, which graph best represents that? But notice this is speed, not height, as a function of time. Now we're looking at these. These are definitely all functions because they pass the vertical line test. But as time goes on here, we see how speed changes. So, what makes the most sense? Well, let's just think first. Sabrina rides up. And as you ride up a hill, you generally would go slower than when you go down. So, if we look at Sabrina's speed here in the first diagram, her speed's quite fast, and then her speed is decreasing. Now, lots of students don't think this is the right graph because, well, if she's going up the hill, it would make more sense to look like a hill and then back down a hill. But remember, this is speed. And so when you're going up a hill, you're slowing down, you're getting more and more tired, slower, slower, slower. You're probably at your slowest point near the peak. And then you start to pick up speed because gravity's finally on your side. It's pushing you down the hill, and your speed starts to max out again as you get near the bottom of the hill. Now, this is definitely going to be our correct option right. Whoa, that was not straight. That's going to be our correct option right here. If we look to the other ones, this is the opposite. You do not start going faster as you go up a hill and then slower as you go down. That does not make sense. And the one on the right doesn't work for the same reason, but also we do not generally go up a hill at a constant rate. We're going to get tired. We're going to go slower and slower. Your speed, again, is not increasing in this rigid form. It would be more of a smooth transition of a curve. All right. Third example, what's going on in each segment of this graph representing a bike ride? Now, you can be fully creative here. I'm just going to say we got a bike rider named Joe. So Joe's riding his bike. And in the beginning segment here, I'm going to look at from here to here. Okay, I'm going to call that number one is this portion because it is a constant. And look at our variables. We have time and we have distance. So we could think of this as perhaps distance from home. Okay, so we have the distance here and over time. So this is how far away Joe is from home. So let's say Joe is going to the grocery store, Costco. Okay, so Joe rides to Costco. Okay. And then there's a problem here. Right from here to here, some type of problem. His distance is increasing as he rides away. It looks like at about a constant speed, but then his distance doesn't change at all, but the time is. So time is changing, distance isn't. So Joe has stopped. So at 2, Joe stops. And what could this be? Maybe flat tire? Could be a flat tire. Okay. Anything, you can be creative there. And then step 3 is going to be from these 2 points. So here's step 3. And Joe is continuing to move away from home, but he's going a lot slower. Okay, so he's going a lot slower here. So maybe he's walking his bike because of the flat tire. Joe walks his bike. Doesn't have a flat kit with him. He can't fix the flat on the way. And maybe right about here, he finally gets to Costco, but because of the flat, Costco's closed. Costco's closed. So he decides, you know what? I'm going to turn around and Joe goes home, but maybe Joe catches the bus instead because of his speed going home is quite quick and constant here. So let's just say Joe catches the bus. Something like that. But you can think of any scenario where you're moving, your distance increases away from somewhere, something delays you, you move a little slower, and then you decide to turn back, whatever that might be. Okay. And that's pretty much concludes this lesson. This is something that you should have been able to do without even me teaching you, actually, just slowing down, interpreting our graph, looking at our axes, the horizontal and the vertical, to see what's going on, and then make a judgment call. Okay. And we'll see you in 4.3.